If heavier were an issue, why did this one not make it down significantly more than this one did? If the weight were an issue. You don't necessarily have to answer right now, but I just want to throw that out there as something that contradicts at least part of what you said. Suppose we did these two balls.
How heavy is that blue?
I think it's heavier, but I am really lousy at judging those things. A little heavier? So if Hunter is right, this one should win? Is that, if I'm understanding what you were saying? It's a little bit
What
heavier.
about that based on the diameter is a lot bigger than this one. I mean, it's like, it has more surface. Well,
Okay, it does have more surface area, it is bigger. How do you think that's gonna affect it?
I just think it's just going, based on those tracks right there, it's going off.
Sorry, missed the last part.
Just based on those tracks alone, it'll beat it down.
Just the bigger one's gonna win?
I don't know, maybe there's more area for the force of gravity to push down on it. I don't know.
There is, the more massive one does have more of a pull of gravity on it, but it also has more mass to sort of fight against that. That's basically if I drop them straight down without rolling, they would hit the ground at the same time. What are the chances it's not gonna roll off the board? They both want to be together. So that they both hold still. White has a slight advantage there, not much. I guess you have the closest view on. Relatively even. And before it crashes into my calculator. That was pretty much close to it. You said this was slightly heavier, so weight should not, and mass should not have a huge significance here, but definitely the diameter did not seem to make much difference, similar to what we had over there. Again, check for board bias and see how long it takes me to get this set up. They were hanging together at least till when it fell off. All right, so size does not seem to have a significant role in it going down. However, ball and hoop, there was a significant difference.
Is your whole table slanted?
Excuse me?
Is your whole table on an angle?
Good, possibly. My experience with my own personal house is nothing is level and there are no right angles. Andre, you sound like you've gone through that yourself.
Yes.
Disc versus thick hoop. Or even thicker disc versus skinnier hoop. So we've established that the size, how big it is, does not seem to have any significant role here. What about this? Which one do you think will make it down first?
The blue one?
Yeah, one is.
So we got big blue with that small hole there. And then we have the black one. And then a tie. All right, so big blue. I'm not trying to force you. That was not a look of, you have to vote for this one. But you're holding out. All right. You going for the hoop or a tie?
I'm gonna go with a tie.
I think everyone else voted for Big Blue. I think. All right. Yikes, I did not want that to happen. Well, there's some damage there. I believe the integrity is still there, but
For extra credit, we won't tell.
and, you know, if you did, then I'll have to buy a new one. All right, and so blue was over there, so blue's now over here. And perhaps protecting the equipment just a little bit more. All right. So blue made it down a little bit ahead. All right, so big blue won both times. Are you satisfied that big blue won? Or are you saying that big
idea
close enough?
why.
Pardon?
I have no idea why though.
So when we dealt with the two hoops, that was roughly a tie. When we dealt with ball and hoop, ball made it down first. We dealt with two annular cylinders with different size holes. The one with the smaller hole won.
And the two big, or the big ball and the small ball,
Say it again?
and the blue ball.
Oh,
White ball.
now, it all has something to do with moment of inertia, but. Anyone want to speculate?
What acceleration and mass were like tied together? But I feel confused now.
Acceleration and mass are tied together.
So the ones that, I don't know, I guess I'm confused because I thought the lighter one would go faster, but like that didn't, so now I feel confused.
So, mass and acceleration are tied together, but also is force. So, but if I drop two objects of different masses, they would hit the ground at the same time. Assuming that it's not fast enough where air resistance becomes a significant factor. But there's something else going on here than just, oh, the acceleration is the same for both of them, because the acceleration clearly is not the same. Connecting it with one other thing, when you say mass and acceleration are tied together, Newton's second law sums it up. Or for rotational motion, tau equals I alpha. Hollow ball, I'm gonna assume that's relatively solid. Solid ball, hollow ball. Solid. I heard solid? Good. We got a vote for solid back there. You have a reason why, or just it feels right?
That's heavier. I'm just going by this.
Going by heavy,
Wouldn't
okay.
wouldn't it be a tie if you're dropping them?
Pardon?
Wouldn't it be a tie if you're dropping them?
If I'm dropping them, yes, but I'm gonna roll these. So solid, hollow. I am assuming, it's possible if I drop it that I don't think air resistance is gonna have a play in this one. It is relatively light. And a pretty sucky ping pong ball. Oh, they all have that same nasty feel. All right. Solid. So that was 8 for solid. So tie still not. Hollow. And I think that's no ties. The trouble with balls. There we go. Solid definitely got ahead there. Well, it seemed like this one got caught up, that I think that was a bad trial, even though I was expecting Solid to win. Besides the fact that this is hollow and that one's solid, what's really the difference between these two?
The moment of inertia.
Oh, yeah, moment of inertia is different, but the formulas give you an idea. This is 2/5 mR squared, and this is 2/3 mR squared. Now, the masses are different and the radii are different. For the annular cylinder, they're different size holes, but it's 1/2 m r inner squared plus r outer squared. And those are just hoops. Oh, same formula. Did you want to expand on moment of inertia or just sort of leave it out there for someone else to pick up?
Yeah, just leave it out there.
Okay, someone else pick it up. She's laid moment of inertia out for you. They're just gonna leave it hanging, it looks like.
I don't know, the radius is smaller, the mass is smaller.
So heavier things make it down first? Is that what we're sort of leaning towards right now? Or, yeah, if we plugged in the numbers, well, mass is smaller, radius is smaller, this fraction is bigger, that fraction is smaller, but I think the difference in the mass and the radius would make this number, ultimately calculation would be bigger. But that wouldn't explain these two, which was pretty much a tie.
Does it have something to do with like how far out or far in the mass is?
Otherwise known as distribution of mass. All right. Distribution of mass is key. That's ultimately what the moment of inertia tells us. It's how the mass is distributed. So, you want to make a generalization?
Is it possible that objects with masses close, like a mass distribution closer to the center will move like faster now?
Yes, it does. Yes, it is. And so I guess we will leave there with why does it make a difference? But the more the mass is closer to the center, the faster it will go. And we saw some of that with I keep calling it a flywheel. I don't think it's necessarily a flywheel, but the disc, keeping energy in the disc. The lower the moment of inertia, the faster we got it. Let me kill the camera first.